Hello, everybody, and welcome to Exchange.js. Despite the fact that you were absolutely certain that it's September, it is not September, and it is in fact October. If that is comes to you as a shock, or I'm the bearer of bad news with regards to projects and other stuff, I'm sorry, but we are in fact in in October, which means it's time for some more wonderful JavaScript content. We have something a little bit different this time because we are looking for speakers, and looking for organizers. It's a new season. If you're here and you're junior to the Edmonton development community, it was a great time to get involved with what I believe is a really wonderful group of people here. I say that because I'm a part of it, and there's some extra awesome people besides me involved, but we'll get to that a little bit later. So what do we have on the docket for today? You will notice that our agenda is now available in dark mode, which is nice. So first, we're going to go over the code of conduct as a talk from the Dev Edmonton community. We have a code of conduct that's applied across all of our meetups. And then we will get into some JavaScript news, and then we will get into the homework portion where we will actually be testing your knowledge and running through all sorts of really interesting things about JavaScript. A lot of the times we focus on kind of the high level stuff, some of the view, some of the next stuff, but we're going to be having some real interesting content coming in terms of learning about low level JavaScript stuff. So by starting this content, by joining us here today, you agree to our code of conduct. You can find a link to it at Dev Edmonton, but in general, try and be kind, be patient, and be awesome. So that means that be accepting of other people, don't be discriminatory in any way, be welcoming to everyone, and make sure that we're kind of putting our best foot forward when it comes to the community. So try and always do things that promote the community and make sure that other people want to come and share with us their awesomeness. If we were in person, we would have these little yellow tags that would denote that you're willing to talk about the community and about Dev Edmonton in general. We don't obviously have those because for some reason we're all in our homes. But just keep in mind that there are some people in the chat or in Edmonton that would be willing to reach out and to share with you kind of the benefits of the community, whether that's answering some questions you might have about a particular language, or some more questions about how do I work with the society in general? How do I navigate all this stuff is this wonderful support network we have in Edmonton. You can always reach out to us in the chat on YouTube or wherever you're watching this. If you're willing to answer stupid questions, then just post there now and say like, hey, you know what? I love this place. Love to talk to anyone new about it. If you have any questions, just let me know. And over there, down in the corner, is my actual email address. If you email me, I will respond. And like I said, there's no stupid question. I get all of the questions, so don't worry about that, whether it's to do with the society or working as a developer or the Edmonton development community. Just reach out, because what really powers this community isn't JavaScript, as much as we'd all love to believe that JavaScript is the fundamental language that underpins all of us. It's our wonderful people, and we would love it if you were new to the community, if you joined us and helped us make it more wonderful. All that being said, we have some news. Like the last couple times I've run this, there's been some variant of Vue.js 3.0 coming soon, new features, and I'm happy to say that it's now out. So if you are in that particular stream of JavaScript, you are probably very excited about all of the different things, the composition UI, and all the different sorts of stuff that you get to work with. There's also a big update in the native script world, as well as a proposal for decorators in JavaScript, which, if you haven't programmed in a language that has decorators, is really interesting. They unlock some really interesting potential when it comes to kind of systematizing the work that you do on an ongoing basis. Being like, I want to write this class, but I don't want to have to worry about logging this particular function, for example. Decorators are really interesting in that regard. And then there's some DHTMLX updates. In particular, they have some increased support for Angular, Vue, and React. So if you were in kind of a pre-built kind of world or looking for a front-end library, that might be one to check out. If you are new or if you somehow aren't on Slack yet, you should get on Slack. It's great. There is a whole bunch of channels. You can see over on the left there, there's one for Exchange.js, as well as there's different ones for opportunities and random. And as you can see, you can talk to eminent people in the JavaScript community like Mark or Abram, who is running tech for us today, or even someone like Ashia or S. Edwards. Lots of interesting people in the community you can talk to. As well, it's a great place to just meet new developers, to cross-pollinate across different languages even. I sit in most of the meetups because all of that talk to me is fascinating. The Ruby meetup is especially probably a very active one. So if you want to get the Slack, just go ahead and follow that link, and then you can join and join in with the rest of us in our wonderful community. This slide doesn't mean that this particular is over. It just means that the next one will be happening on November 5th, 2020. Hopefully, with it being the 5th, not the 1st, you won't have that feeling that it was just September yesterday. And it will likely be online again. We're kind of stuck here until we can get all of this under control. We also do want speakers. It's the start of a new season, which means that we need content. We are going to be hopefully laying out the next 6 to 9 months of talks, depending on how it works. Our kind of core business hours of talks at Dev Edmonton and Exchange.js is kind of the September to roughly June kind of range. And so we're looking at filling that out and getting some regular ideas. Really on the hunt for new blood when it comes to helping guide this machine along and making everything kind of work well. And so it's a fantastic way to get involved at a high level, and it looks great on a resume. I'm just going to throw that out there. If I see someone's an organizer of a community, that's always something I look out for. So again, you can reach out either through the talks page. We'll probably have an updated link in the Slack afterwards because the organizer drive is a bit of a new initiative for us. But again, you can always reach out to my real actual email address. Please don't sign me up for anything at this point. And with that being said, what we have is a little bit different here. We are going to be looking at JavaScript operators, and this is going to be a really fascinating talk because if you haven't unlocked some of the features of JavaScript in terms of all the different operators you can use, this should hopefully be kind of eye-opening. So I believe I will summon Abram, I believe, below me. He will pop in a second, and we'll introduce. Oh, here he comes. There he is. Excellent. So why don't you give us an intro as to what this is going to be, Abram? Oh, he can. If he can. He's also running tech. He's doing so much today. He's organizing all the talks. So
yeah, so it's a little complicated. This is a setup of 4 different talks on operators, and we'll play the video. These were pre-recorded, and then we'll do exercise and questions afterwards, which will be on YouTube. We'll answer the questions on YouTube. Okay? All right, thanks.
And now I will vamp until the video comes up. Ah, excellent. We have the video. I will shut up again.
Hi, and welcome to my talk on the nullish coalescing operator in JavaScript. This is a new operator that's in ES 2020, so it's relatively new. You'd need Node 14 to get it. It works in most modern browsers. It might not work on Android, Firefox. It might not work on some of the mobile browsers. You might have to use Babel and polyfill it back in to get it. But it's a really neat operator that you can use to deal with values that are either undefined or null. So what we got here is we got Node.js, a JavaScript REPL, so I can do any kind of JavaScript-y kinds of things. So I could go, here's a lambda that does 2 times I, and then I could say, give it a 1, and it returns a 2. Now, oftentimes your functions have optional arguments or default arguments or arguments that won't be set. And so inside your functions, you often want defaults. So you could imagine that you might go varx equals, well, let's just set varx to 10. We'll go var y equals X, or if it's not X, we're going to set it to 1. So what is Y? Y is 10 because X has a value. So let's go var u equals undefined, such that we know that u will mean undefined for this presentation. T will mean true, and we'll go F for false. So we got false, we got true, we got undefined, n equals null. Okay, so now if we want to set y to something, we could say, well, set it to n, or set it to false. Okay, so now what is y? Y is false. Now you're thinking, but you could just use the pipe, right? That's true. So let's just try it out. So I'm going to use the logical OR to set it. What is y? Y is still false. That makes sense, but it's still the last value. But what if I want to set y to be false anyways as the argument, right? And maybe we've got another value. What is y? Y is empty string now. So that's kind of a problem. Logical OR will take any value that's falsy and it will treat it as false. Whereas the null coalescing operator will treat things that if they're null or undefined, it won't pass those on. So if we go var y equals, well, I can just go y equals f coalesce empty string, y is now false. So essentially what it's doing is it's saying, is f, is it undefined or is it null? So we can go, is it null or false? And y is still false. We can go y equals, did I set true? Yeah. So we can go y equals nft. And in this case, it will give up once it hits f, because f is not undefined and f is not null. So it will return this as the value. So we can have a whole chain here. So now I'm using 3 null coalescing operators. So we can go y equals null, y or undefined or false or true. And it's still false. So that's pretty cool. So probably the best way to use this would be to use it to have default arguments if you didn't want to do it the ECMAScript or the ECMAScript 2020 way. So an example would be function, and we're going to have it. This function is just basically going to be the log function, but it's going to have a default parameter. And we're going to go x is equal to this, or it's equal to 1, 0. And then we're going to return math log x. Okay, so if I run log and I just go log, it returns 0 because math log 0 is that. Or sorry, math log 1. So if it was undefined, what we'd find is we'd return a nan. But instead, it's saying, oh, look, if x is not defined, as in I didn't provide it, so it's like I didn't even provide it, we'll set it to 1, 0. But will it work when I give it a falsy value like 0? Yeah, it still works, and it gives me negative infinity, which is perfectly fine. It'll also work when I give it 0. We can give it an empty string, which shouldn't work, but it does. So the null coalescing operator is really great for default arguments, or arguments that you're going to set to null, but you want to set to null or undefined, but you want them to actually be set up. So this can be pretty good when you've got like a collection, like it's got a collection like this, and then you want to grab something from it. or give a default value. So you can use it to basically check your properties on your objects to make sure that they're not null or undefined. Now, it does work with null and undefined. So I don't think there's a non-null coalescing or just a purely undefined operator. But this is pretty useful. So default arguments and safety checks with default values is where you'd use the null coalescing operator. It's pretty new, so it'll work in the latest browsers, but you probably need to use something like Babel and polyfill in a version of the null coalescing operator. I hope this makes sense, and thank you for listening. All right, so we'll take questions and we'll get the exercises up on the screen on the slides. So questions in the YouTube. All right. Turn the full screen off.
Sorry, I'm going to have to reshare my screen.
All right. So any questions about the null coalescing operator? YouTube is delayed. Yeah. Okay, so we're good. All right, add the stream. Okay, so you can come up with a question, or we're going to spend a couple minutes on this exercise. The exercise is return the property bar from object foo if it is undefined or null. But if it is undefined or null, return -1. So either make a function that does that or just the one-liner. Just try it out. See if you can use the null coalescing operator. Okay. I'll help you out on the YouTube. Okay, well, let's check your homework and paste what you got into YouTube, into the YouTube chat, and we'll just go over some of it. The trials and tribulations of interactivity in the COVID age. Okay. Well, let's try to solve this, Ian. What do you think?
Oh no, are we live coding together? We didn't plan this.
Oh, I think Andrew's got something interesting. Oof. Wow. Andrew's one is really cool. So Andrew has open paren foo, null coalescing operator, empty object, close paren, dot bar, null coalescing operator, -1. So if foo is undefined, he's going to provide a default object to operate on, and then he's going to get the property bar from it. And if that thing is null or undefined, it's going to be -1. Wow, that's above and beyond what I was expecting. It looks very indecisive.
Okay. That's funny. That's funny.
Let's move on to the next one, which is actually by Andrew.
Excellent.
Thank you, team. All right.
On that, we have another video from Andrew. Andrew, you don't have to worry about turning your camera on. It's fine. So we will pull up that video in a second. And this one is all about bitwise not operators.
Okay.
Also, Eddie, if you're going to do a talk, it's not really great to troll people in the comments.
Hi, let's talk about the bitwise not operator. It flips 0 bits to 1s and 1 bits to 0s. Let's take a look at an example of where we might use that. Here we've got a file with some Unix permissions, rwx for the user, for the group, and for others. In Node, we access these permissions with the stat call from the fs library. Let me just load that. The mode returned by the stat call is a number that doesn't make a lot of sense in decimal. Like 33259, what is that? Well, we can convert it to binary using the base argument for the toString call. And if we copy that over and line it up with the Unix file permissions, it starts to make a whole lot of sense. A 1-bit enables a permission and a 0-bit disables that permission. Now let's say we want to write a function that removes the write permissions for the group and for others. For others, we'll want to disable the 10 bit, and for the group, we'll want to disable the 10000 bit. The JavaScript code for that is let new mode equals the previous mode, bitwise and, the bitwise not of 10, bitwise and, bitwise not, 10000. And converting that to binary, let's compare with what we had before. And this is great. We've flipped the 1 bit that we didn't want to have set. So let's load the function to actually apply this new permission to the file system. Await change mod foo new mode. And let's run ls to see what the new permission is. And if we line it up, there, we've successfully removed the group and other write permissions from this file without affecting any other permissions. Of course, having binary literals in your source code isn't so great, but there are symbolic constant names that we can load from the FS library that will make this code a lot more readable. The names are SI for stat of an inode, and then write other, and SI group other. No, sorry, write group. And so require FS. The permission we calculated before was 33257. Now let's write that much more readably as mode and not write other and not write group. And again, we got 33257. So that's how you use bitwise not. Now I want to go a little bit deeper here. Let's take some small example number like 25 and look at its binary representation. Now you might think that to get the bitwise not of this, that we'll just flip all the bits. So it'll be 00110. But that's ignoring the fact that there's actually an infinite sequence of zeros in front. And so when we do the bitwise not, we get an infinite sequence not of zeros, but of ones. Now our computers don't have room for an infinite sequence of 1 bits. So JavaScript sets a limit for the bitwise not operator at 32 bits. So to actually get the bitwise not of 25, according to JavaScript, we are going to need to truncate this binary number to 32 bits. To get that in decimal, we need a binary prefix, and then we're going to need a bunch of ones, 32 minus 5, because we have 5 bits already, and then the 00110 that we expect. And if we eval this, we get the bitwise not of 25. It's 4 billion 294,967,270. To check our math, let's copy that, apply bitwise not to it, and we should get 25 back, which we do. But let's ask JavaScript, what is the bitwise not of 25? JavaScript says that the bitwise not of 25 is minus 26. What's happening is that minus 26 and that 4.29 billion number we got have the same bits. It's just one's being interpreted as a signed integer and one as an unsigned integer. So because of that 32-bit limit that JavaScript puts when you're working with these bitwise operators, we end up with multiple different numbers that overflow that silently get mapped to the same thing. So all the problems of C signed versus unsigned confusion creep back in here when you're using these bitwise operators. If the absolute value of the number you're giving the bitwise not is less than 2 to the 31, then because of how 2's complement works, then you will actually get that the bitwise not of x is negative x minus 1. So let's write a little function to check that and play with it. We'll call it verbose bitwise not and just show x and bitwise not of x and whether it's equal to negative x minus 1. So for 25, this relationship holds. For 0, it holds. For 2 to the 32 minus 1, it does not hold. And for the bitwise not of 25 we computed earlier, it also does not hold because we're dealing with overflow. If you really want this to work, you can use big nums. Can't mix that here. I'm going to have to redefine that quickly. Where is that? Okay. Yes, let's just add an n. All right, so if you use a big int, then this relationship does hold, but then you might as well just use minus x minus 1. Now let's take a look at another situation I came across where I saw someone using bitwise not. That was actually what prompted this talk. Abram asked what operators, and it was like, oh, the last time I had to look up what an operator did, I was coming across an unusual usage of bitwise not. It's in the Mocha source code, so let's go take a look over there. This is using bitwise not applied to index of as a shorthand for a Boolean. So it takes a little bit to think about, but if index of returns -1, then bitwise not should turn that into a 0, which should turn that into a Boolean false value. Let's check this out in the interpreter. 1, 2, 3, index of 2 gives, okay, 2 is at index 1. And if we take the bitwise not, then we get a non-zero value. But if we ask for something that's not there, then the bitwise not of index of the -1 gives us 0. Now, it probably didn't exist yet when this code was written, but nowadays I'd recommend just using includes for this. It gives you a Boolean value straight up, no dealing with these unusual bitwise operators. This can actually go quite badly. We saw earlier that there are multiple numbers that map to any given bitwise not value because of the signedness and unsignedness and 32-bit truncation. So if we have a big enough array, there are going to be indexes whose bitwise not is going to map to 0 and that are not -1. So if we pop over to Chrome, we can actually just demonstrate this quickly. Now, at the moment, you can't directly create an array or string that has 2 to the 32 elements in any browser that I'm aware of, but you can create a WebAssembly memory that has that many elements and get a typed array to access it. Let's create a new WebAssembly memory and with an initial size of just 1 and a maximum of 2 to the 32. But this unit is actually in 64 kilobyte page increments. So we're going to say 2 to the 32 minus 16. And so create that. And now we're going to grow it. So we want it to be the size of 2 to the 32 minus whatever the current size is. But then again, dividing out by the number of 64 kilobyte pages. So we've got that. And then how big is our buffer? It is, looks like 2 to the 32, is actually 2 to the 32. And so now we can create an array that's backed by that. So an 8-bit array backed by that buffer. And so we can say, okay, the 12th element is 1. What is the index of that? Okay, so that worked just fine. And let's write a little function that uses this bitwise not operator. Let's just do the Boolean conversion so that it is totally unambiguous what Boolean value comes out. And then bitwise not of the index of n in item. So if does 1 exist in the array? Yes. And now let's set a very high element to be 2. And let's try our exist function. And it takes a little bit to scan through 4 billion elements, but we get false. So bitwise not handy in some situations when you're dealing with C code. All of the issues around C applied. Please be careful. Thank you.
Oh, that was so cool.
Wow. Thank you, Andrew.
Yeah.
Andrew's in the comments and he's willing to, he's in the YouTube chat. He's willing to answer your questions.
Absolutely. So if you've got any questions, oh, I'm off the screen.
Yeah.
If you've got any questions, put them in the YouTube channel and we will get those questions answered.
And we got an exercise.
We do have an exercise. While we're getting to the questions, I think I'm going to throw the exercise on the screen. I'll explain this one.
Using the bitwise not operator and optional logical operators, make a function that tells you if a 32-bit signed integer is negative. So that's the exercise.
Excellent.
So we'll give everyone about, I think this is a 2 or 3 minute one because it requires a test. So anyone got any possible solutions?
I haven't seen any in the chat so far, but there's about a 30 to 40-second delay for us.
That's true. Oh, we stumped the presenter. Uh-oh. That's not good.
I was going to say it'll be hard to follow that, knowing that I think you're up next again. But if you're stumping the presenter, that's a pretty good flex.
Oh, well. I'll give the audience a tip. Test -1, test 0, test 1. Those are 3 good test cases. Test them with maybe the bitwise operator, and maybe something will pan out. Right.
I think we might progress and just leave this one as a bounty. If anyone wants to solve this on the Exchange.js Slack afterwards as a plug, I will give you an awesome point. I will permanently get a piece of paper, attach it next to my computer, and write down your name so that we have a permanent awesome point for you.
My solution's only going to be shared once we have another solution.
Yeah. All right.
Okay.
Next up on ours, we have the comma operator. So take us away past Abram.
Hi, I'm going to talk about the JavaScript comma operator. The comma operator has caused numerous problems in C, mostly due to interaction with precedence. If you use comma operator in the general expected way, it's supposed to allow you to have multiple expressions, such as 1, 2, 3, undefined, 4, and it will return the last one. But it will still run the ones in the middle. So if I go and change this and I go x equals 3, and then I go x times equals 3, and we got the 4 there, it still returns 4, and our x should be 3 times 3, 9. Okay, so the comma operator allows you to chain a bunch of expressions together. It doesn't work so well with statements. So watch this. So if I go x equals 3, comma 4, x is equal to 3, and 4 was the return value. So this means that if I'm doing an assignment, the precedence means that this binds pretty heavily. So if you do something like let y equals 3 comma 4, you're going to have a problem. What you can do in this case is you can cover it in parentheses, and then we'll see that y is now equal to 4. You get similar problems with, say, lambdas. So if I go f is equal to the lambda of x squared, comma, the lambda of 2 times x, right? We've got ourselves a function, but which one do you think it is? So I'll go f of 9, and we got 81. 81 is 9 times 9. Okay, so it chose the first one, and that's because of the precedence. So you really got to watch out with the precedence of this operator. It can operate in very confusing ways, and you should use parentheses a lot if you want to use it. Because watch what happens when I run the same thing again, but I treat the expression as a function, and then I give it a parameter. So I'm saying one of these lambdas is going to be returned, and I think you can guess which, and we're going to then run it with the value 9, and what we get 18. So this means that we know that this lambda was built and basically thrown away, and then this one was built and returned, and then 9 was applied to it. Okay? So really watch out when you're using the comma operator, and assignment, let statements, any kind of statement can be quite confusing. So in general, I'd recommend avoiding the comma operator. And it can go pretty deep. So, you can go 2, 2, 2, 2, 2, 2, 2, 2, 2, and, just create a bunch of stuff and just ignore it, return 4. So you can go as deep as you want. Most people are only going to go 2 or 3 deep. Where JavaScript programmers use it is usually in the for loop. So here I got for I equals 0, for j equals 0, I plus j less than 10, I plus plus, and then we're just going to console log that right now. So we're going to console log a list of ij. So we're good to go. The for loop, right, returns 0. The for loop returns an undefined. That's fine. And we can see here that eventually I is incremented. So we initialize both of these, but j never changed. So let's change it. Let's change here in the incrementer to be j++. This way we'll increment both I and j. And you can see here that it stops when they're about 5, 5. Right? So that makes sense. Be aware that it doesn't work for the middle one. So I could go I less than 3, comma, I plus j less than 10. This is going to be confusing. It's really just going to ignore this expression, and we get the same result. Okay, so where to use comma operators? Typically in initializers and the accumulator part of for loops. Don't use it in the condition part. Try to avoid it in general expressions. It's very confusing in assignments, but one place it's used a lot is for chained assignments. So you can go I equals 1, j equals 2, k equals 3, and then we'll see that it returns the 3, but the other ones are set just fine. Just be aware that gets very confusing if you do something like I equals 1, 2, 3. What do you think I is in this case? Yeah, it's 1. So the second one was totally ignored. Okay, so be aware of the comma operator. Be aware that it can be abused. And one common thing that people were using it for was a semicolon replacement. So people would go something like I equals 3, comma, and then they go I times equal 4, comma, I plus plus, comma, I. So what happens is we got I equals 3, we then multiply it by 4, so it's 12. We increment it once, and we then run another expression to return it. So that's another example how people would use it. I would generally avoid the comma operator other than for multiple initializations in a for loop. All right, thanks for your time. All right, so that's the comma operator. Let's check out the exercise and answer some comma operator questions. The most
Excellent. I can't wait.
JavaScript operator. All right, so the property k of a brace k close brace should be a list. So you're expecting a list. Using the comma operator in one line, return a of k, or k of a, but if k of a doesn't exist, set k of a to empty list and return a reference to that empty list that you just assigned to k of a. So when I say k of a, I mean k is a property of a. All right, so we got an exercise, and we'll also answer questions in the YouTube chat. Thank you. All right, do you got a question? Ternary operator is pretty good. All right, well, share your answer. We'll give it a shot, unless it's just simply the ternary operator. Oh, I see. So that's to the is if negative absolute value less than 2 of the 31 thing. I see.
I think he's talking about the previous exercise, actually.
Yeah. Okay. A hint for this exercise right now is null coalescing operator is your buddy. You can chain these things and make a horrible monstrosity of default value.
Now, building on previous things, you aren't trying to teach us something, are you, Abram? That would be bad.
Maybe you shouldn't have used operators. Replace them with words, then it's a-okay. Everyone's fine with it. Okay, so one idea is you have the null coalescing operator, and if a of k exists, it returns a of k. If it's undefined, aka the property doesn't exist, then it goes and does something else, and that's where your comma operator could be really handy. All right. Yeah, Andrew, post your solution. Do it. Anyone got a solution for the current exercise? So I'll give you half the solution. Half the solution is this. So a of k, did I want to, oh, I did it wrong. There's a bug in mine. A of k should be empty list, comma, a of k. So that'll return the empty list, but there's another half part.
Abram, the slides are still up. I'm not sure if you're trying to share something else.
No, I'm just reading Andrew's thing, sorry. Okay, so I'll address Andrew's question during Eddie's talk, I guess. Does anyone else have any other solutions for this exercise? No, you don't need the comma, but the comma is nice. You're right. You can actually just return the whole shebang as an assignment. So the comma is unnecessary. Yeah, Eddie's very clever. Okay. So we'll move on to Eddie then.
Excellent. So I believe Eddie is up next with the arrow operator. So, aha, we have summoned Eddie. Can we hear Eddie? We can hear Eddie. Fantastic.
All right.
So take us away.
For sure. All right. Let's talk about 3 different ways to write JavaScript functions. And here you can see I have my lovely ASCII art introduction. So 3 different ways. There are function declarations, function expressions, and arrow functions. Let's talk about declarations first. So your function declaration, of course, has that function keyword and has the braces. It usually has a return statement, an explicit return statement. These are your ordinary functions. Now, compare that to function expressions. Looks the same, right? It has the function keyword, has braces, but there is a difference in the context that it is used. And I will get to that. And then there's the new kid in town, the arrow functions, which is a much more concise syntax, of course, noted by the equals and the greater than sign, which, like, to me is just, I just look at it as an arrow. And all of these functions do exactly the same thing. So what's the difference then? Let's talk about the difference between a statement and expression. So the function declaration is a statement. What does that mean? You use it in the same context that you'd use a var, let, or const, right? So the same way that you'd create a variable called address with the keyword var, you would create a function with the keyword function, which declares it in the current scope. Now, a freaky thing about JavaScript is that the var keyword and the function keyword are hoisted. Hoisted means that no matter where you define the var or the function in the current scope, it's as if you defined it at the very top. It's hoisting it to the very top. So here, I've said console.log my variable. But then afterwards, I said var my variable. My variable exists as if I put var my variable at the very top. The same thing happens with the function declaration. You can define the function after you use it. I actually think this is rather useful. Maybe some of you will disagree with me. Maybe you'll think it's gross. But for example, if I just want to say console.log say hi, and then wait until later to define what say hi means, I can do that. How do I use that? Let's say you're writing some big, gnarly algorithm and has a bunch of different steps, but those steps can be concisely described. You can absolutely have helper functions defined within, and then use those helper functions before the return statement. That is syntactically valid. I like it. You may not like it. I don't blame you if you don't like it. So those are statements. Those are function declarations. Let's talk about expressions. So the function expression, given its name, is an expression, and so are the arrow functions. So you use expressions in the same context where you'd provide an argument to a different function, or if you'd assign it to a variable. So the same way you can assign the number 1 to the variable A, you can assign a function to the variable B, or an arrow function to the variable C. You often see this with any functions that take callbacks. There's a bunch of callback-based programming in JavaScript. So set timeout is one of the oldest functions that operates this way. Its first argument needs to be itself a function. So typically you wouldn't see a name there. You'd actually see a function expression there, or an arrow function, which provides what to do. So both of these lines say will log hi after 1,000 milliseconds or 1 second. So arrow functions tend to be more compact than the function expression notation. So here I have 2 lines. Both of them take an array of numbers, and they just square them, right? So return x times x. But you'll see the arrow function is much easier to express. I can get rid of some of those parentheses. I can get rid of the braces and get rid of the return. And it does exactly the same. Like in this case, it has the exact same functionality. So you may conclude arrow functions are the same thing as function expressions, but shorter, right? Not quite. It all comes down to what does this mean. So in old school function expressions, the thing that this refers to gets lost. So say I define a class, and I have in the method, say name later, I have a set timeout. And I gave it a function expression, and I said, after 1,000 milliseconds, log this dot. Oh, that should say this dot name, not this dot Eddie. Will log this dot name. With function expressions, it's freaky because this is dynamically bound. I'm not going to get into too much what that means. But typically, you want the this here to be the same this as in the method that you're defining, and the same this that refers to in the class. That's just not the case with function expressions. This will be maybe the global, or it might be undefined. It really depends on how the say name later method is called, which is very distressing. Old school JavaScript programmers will remember doing a hack like var this equals that, or var that equals this, and then using that instead of this inside your function expression. Very straightforward talking about that and this. Well, arrow functions are newer. They decided that this should be lexically bound, which is what you, this should be. So with a lexically bound this, it makes sense what you want. So you can write this arrow expression, and this still refers to what this means in say name later, which refers to what it is in the class. Typically, the arrow expression uses this properly. So let me give you a little warning about the arrow function notation. It's a minefield of syntax. There's a lot of little subtleties going on in the syntax. So the braces affect implicit return. So what do I mean by that? So here I've made a function called call_print, which takes a function and calls it and prints its output. So if I give it this arrow expression, this arrow function, so 2 + 2, that's going to automatically return 2 + 2. It's going to print 4. If all you do is write that again, but with braces around the 2 + 2, it's going to print undefined. And that's because JavaScript completely changes the way that it reads the thing after the arrow. So in the first statement, it reads the thing after the arrow as an expression to execute later. In the one with the braces, it interprets whatever is in the braces as a function body, which means it's just like any regular function. You have to use return. So if you want those braces there, you have to explicitly write return, and it will work properly. So now you know that's the difference between the 3 different kinds of ways to define functions. And ask questions. I didn't know there would be homework assigned or challenges, so I don't have anything. But that's my spiel.
You would think there's not homework, but actually there's homework. That just means that you can also do it. So go right there, and you will see the exercise that we have generated from arrow functions.
Should I read it? Should somebody read it?
I'll read it.
Go for it.
Okay.
And I'll stop. So with the arrow operator, make a function that takes a string argument and returns a single argument function. So a function that makes a function that will split that string. So we'll imagine that your function is called f, and we give it a, comma b, comma c, comma a, semicolon b, semicolon c. It returns a function, and then that function takes what to split on, and it returns the split. So see if you can do that. All right, I'm going to remove myself, and we'll leave Eddie to answer questions from YouTube.
Where did my comments go?
We have a question from Ronsky Mountain. I'm sorry if I'm mispronouncing that. Asking if the arrow function is kind of the modernized function.
Sort of, yeah. So I did want to make a distinction between function declarations and function expressions. I think function declarations still useful, still bomb. But arrow functions can be used in the same place in function expressions, and especially if you use the word this in your code, they're less confusing. They also require less typing. So yes, arrow functions are newer, and whenever I need an expression, I'll probably go for an arrow function. But these guys, my good old function declarations, my good old statements, they're still useful. So don't just, go into your code base and delete all of your functions with arrow functions. It's not the same.
Also keep in mind, if you write an arrow function, I think depending on how you write them, they might not have a name. So when you're
that's true.
As well, it'll be hard to find a particular function in like your call stack or something, because you won't know exactly what has been executed. I believe you can generate them with names. Like if you use if you declare them as like a variable, and it will be
const
const
whatever function.
My function equals arrow function something. But in like say the timeout example for that won't have a name, and so if you're debugging,
your stack traces will just be like anonymous function. Yeah. In which case, your function expression, you actually can't. So I realize my screen isn't up, right?
No, it's this slide.
So yeah, you can with function expressions, you could be like, hey, this is my function, right? I'm good at typing right now. And if you get a crash, you'll actually see that. Whereas with arrow functions, and you can even do that not just in this equals thing, but also wherever you would use one of, where are we? Yeah, right here, right? You could say log later.
The other classic example.
Yeah, and then this will not have a name, as far as I know. I'm not like 100% sure, but like, where would the name come from? Who, But yeah, this one would still have a name. It'll show up in stack traces, and like even set timeout, if it wants to, can access the name of the function that was passed to it. So again, they are different.
Yeah. For the second question, follow-up from Whiskey Mountain is more efficient to use the arrow function.
Not at all.
It's more in terms of screen real estate, and so for that second set timeout, it's more condensed.
Yeah.
But code golf is not really a thing to really focus on.
Yeah.
It's more just a thing to be clear. And if you're using something like React, it also that might obfuscate something. Like if you have anonymous functions in your render, for example, you have a bit of a memory performance issue there. So you want to make sure that you're always using like the correct sort of format for your correct.
Yeah, it depends on the context. So here, if I was reading this code, I would rather read this than this, because this provides a lot of noise. But if you've got a lot of things going on, in the inside, in the body, then it's like maybe the function expression makes more sense, right?
Last question from Abram. And as a reminder, there is an exercise that hopefully you all should be working on if you're all working hard. If you have any answers, post them in the chat. If not, we'll give it kind of a few more minutes, and then we will move on to the final part of our presentation. But Abram is asking, is there a performance difference between arrow and function? Is it a closure?
The arrow and the function, I am unaware of any difference. I would assume that JavaScript engines would automatically figure things out. However, if you're using like Babel or like a transpiler from 2015, before arrow functions were, supported by default in JavaScript engines, the way they would fake this, right? They literally would do this. Like the compiler or transpiler, whatever you want to call it, in order to fake an arrow function, to make it work in older JavaScript engines that don't understand arrow functions, they would absolutely create an alternate variable, or maybe they'd call it like, underscore this. And every time you wrote in your source code this, they would change it like that. Oh, these words. So the answer is complicated, but I would not worry about the performance difference between the two at all. Like, it's not a concern for me.
Excellent.
Yeah.
Well, we don't have any more questions, and we don't have an answer to the exercise. I think what we'll do is we'll post all these exercises in Exchange.js in the Slack afterwards. So if you want to take a gander at them afterwards, that'll be a fun exercise for the group.
I wonder what Abram's favorite Indian food is.
I'm not really sure how to answer that question.
Abram gets it.
It's curry.
It's curry.
Okay. Thank you so much for your presentation and for having the courage to do it live.
Sure.
That's excellent. Thank you very much.
No problem. Thanks for having me.
Absolutely. So As I mentioned before, the Exchange.js is part of the Dev Edmonton Society, which is a kind of a loose gathering of Edmonton developers from all different varieties. We have very well attended meetups in the Ruby space, in Python space, in the in the Go, and the .NET. There's lots of different meetups that we support, and it's really a framework for us all to meet and to gather, even virtually, and trying to figure out like how we can get everybody together and like acting and learning together as well as increasing that cross-pollination. If you're interested in the business of the Dev Edmonton Society at large, we meet on the second Wednesday of every month. So I believe the next one will be on the 14th of October on the Wednesday at 8 p.m. Meetings go anywhere from about an hour to more like 2 hours. There'll be a Google Meet link. And as always, you can check hashtag Dev Edmonton Society in the Slack to find the agenda and details. As a reminder, the Dev Edmonton Society has a board, and we are going to be having elections in January at the annual general meeting. I believe that the COVID tracer review link is a little old, but there is also some interesting stuff happening on the Slack always. Dev Edmonton also exists due to the generosity of our sponsors. And so thank you to all of the people that are our sponsors, including Punchcard, the fantastic company that happens to employ idiots like me. We do software consulting and do a variety of different things in the mobile and the web and the SharePoint space. In addition, there's Jobber, which has a really interesting product kind of based all around the idea of empowering different people to offer services. It's a really cool product, and they're really big in the Edmonton industry. And I believe finally we have Iron Sights, which does some work around kind of tooling for the oil and gas industry, kind of providing really advanced and interesting software solutions to all of the problems that whole industry has. Thank you to all of them for sponsoring. If you would like to sponsor us, definitely give us a ring at sponsors@exchange.js.com. We still do have budgets for things like hosting and software costs and all of those things. And when we are all in person again, we will have budgets again for things like food, as we can all share in each other's space. As we come to a close, I'd like to just remind everybody that the next meetup, again, is the first Thursday of every month, November 5th, 2020. And I'd like to remind people that we put out a call for not only speakers, but also organizers. As we move into the new year, it's going to be important for us to make sure that we have enough people doing all of the things that it takes to keep all of this running, including whether that's asking for talks, whether that's running AV, whether that's emceeing like I'm doing now. There's lots of different ways you can get involved, so please reach out. And I believe that is the end of our talk. Normally we have kind of a social event, and we're doing it virtually, of course. So I will post this link in a second in the YouTube channel, and I will post it again in the Exchange.js. But thank you everyone for coming. On this some cold afternoon, as it's colder and as the calendar shifts abruptly, we're glad that you could take some time to learn some really interesting things about JavaScript. I'm not sure if you were smiling the whole way through, but I was really enjoying all of the deep dive on all the different JavaScript operators that we've probably used once and probably incorrectly, and so learning all their ins and outs is fascinating to me. Thank you all for coming, and as always, we live on the Slack, so we hope to see you there as well. Thanks, everybody, and bye.